Hello my dear students, today we are going to discuss topic on modern layout of thermal power plant in power plant engineering. These all points are covered in this lecture. Introduction, classification of power plant, general layout of modern thermal power plant, site selection of thermal power plant, merits of thermal power plant, demerits of thermal power plant, and state-wise India's thermal power plant. Now, first of all, starting from introduction. Power plant is an assembly of equipments that produces and delivers mechanical and electrical energy. The electrical energy occupies the top position in the energy grids ranking. It finds unaccountable uses in home, industry, agriculture, and even in transport. The electrical energy is a convenient form of energy because it can be generated centrally in bulk and transmitted economically over long distances and is almost pollution free at the consumer level. Electrical energy is generated by conversion of energy available in different forms from different natural sources such as pressure head of water energy, kinetic energy of flowing winds, solar energy, geothermal energy, chemical energy of fuels, and nuclear energy of radioactive substances. Classification of thermal power plant. First one, according to type of fuel used. Steam power plants, diesel power plants, gas turbine power plants, nuclear power plants, and hydroelectric power plants. Second one, according to mobility of plant. Stationary power plants, mobile power plants. Third one, according to nature of load, base load plants, peak load plants. Fourth one, according to nature of organization, central power plants, captive power plants. General layout of modern thermal power plant. Basic components of the thermal power plants. First one, furnace to burn fuel. Second one, steam generator or boiler in which heat generated in the furnace is utilized to convert water into steam. Third one, prime mover. It's called steam turbine. To use the heat energy of steam and converts into mechanical work. Fourth one, piping system to convey steam and water. Fifth one, electrical generator or alternator to convert mechanical power into electricity. We can show the schematic diagram of thermal power plant. The entire arrangement for the sake of simplicity may be divided into four main circuits as first one coal and ash circuit, second one air and flue gases circuit, third one feed water and steam circuit, and fourth one cooling water circuit. Starting from first circuit coal and ash circuit. Coal received in coal storage yard or power station is transferred to the furnace by coal handling plant. After necessary preparation of the coal from coal handling plant is taken into the boiler bunkers by means of bucket conveyors. Then the coal is stored in the bunkers. Coal from bunkers falls into the hoppers by gravity, and finally the requisite quantity of coal either goes on falling directly on grate or where the coal spreaders are provided. Coal is spread in the grate up to rear end with the help of coal spreaders. Ash is the product of coal combustion in the furnace. Along with flue gases, about 20% of the ash falls in the bottom ash hopper of boiler and is periodically removed mechanically. The ash from hopper is removed to the ash storage by means of scrape conveyors. means as handling plant. Further as deposit of in accordance with as disposal arrangement. Second one, air and flue gases circuit. The air is taken from the atmosphere by the action of a forced draught fan and passed through an air preheater where it is preheated by the flue gases. The preheated air is supplied to the furnace in order to provide air for combustion of fuel. Due to combustion of fuel, as a fuel there is a coal. Hot gases mean flue gases are produced. The flue gases from the furnace pass over boiler tubes and superheated tubes. Then flue gases pass through economizer in which water is heated and air preheater in which air is heated. Flue gases is then passed through dust and fly ash collecting device where suspended dust and fly ash are removed from it. The fly ash is separated from flue gases by means of ash precipitator. Finally, flue gases is exhausted to the atmosphere through the chimney. Third one, feed water and steam circuit. The condensate means water which is converted from steam is extracted from the condenser by the condensate extraction pump and passes through low pressure feed water heater. The temperature of water is raised in the feed water heater by the heat from steam which is extracted from the lowest pressure extraction point of the turbine. The feed water then passes through deaerator and high pressure feed water heater where it is heated by the heat from steam which is extracted from the turbine at suitable point. The deaerator removes the dissolved O2 from the feed water means condensate. Then feed water is heated in economizer and fed to the boiler with the help of the feed water pump. In the boiler, water is converted into high pressure steam which may be wet. The wet steam gets superheated when it passes through the superheater. The superheated high pressure steam is supplied to the steam turbine. The steam first expands in high pressure stages of turbine and then expands in low pressure stages after reheated in the reheater until it brought to original dryness or superheater. After the expansion, steam is passes through condenser where it rejects heat to cooling water and condense. The condensed steam means condensate again feed to the boiler. A part of steam and water is lost while passing through different components in order to compensate mass of heat. The water is added in the feed water system as makeup water in order to avoid scaling and deposition in the boiler tubes. The feed water supplied from external source is passed to the purifying water treatment plant to reduce the dissolved salts. Fourth one, cooling water circuit. The function of cooling water is to absorb heat from steam which is coming from turbine and to condense the steam. Cooling water is supplied from natural sources such as river, canal, sea or lake. Cooling water is passed through the condenser and absorbs heat from steam, hence it is heated. The heated cooling water is discharged to the lower side of the river when the adequate fresh water is not available for condenser. Then the hot water coming out from the condenser is cooled either in cooling pond or cooling tower. In cooling tower, the evaporating cooling takes place and there is loss of water. In order to compensate this loss, the water from the river is continuously supplied. When the cooling water coming out, the condenser is cooled again and supplied to the condenser. Then the system is called as closed system. When the water coming out from the condenser is discharged to river downward side directly, the system is called as open system. Main components of the thermal power plant and their function. First one, boiler. It is a closed pressure vessel in which the water is converted into steam with the help of heat produced by the burning of coal. The modern high pressure boilers are all water tube boilers in which water flow through the tubes and the combustion gases flow across the tubes. The high pressure boilers contains separate set of tubes which constitute heat exchanger as follows. Superheater. It is used to raise the temperature of steam above its saturation temperature. The superheater is located at the hottest part of the boiler in the furnace. So that heat is transferred to steam by superheater from the hot gases. Reheater. It is used to raise the temperature of steam after it is expanded in the high pressure turbine. After reheating, the steam supplied to the low pressure steam turbine. Economizer. The function of economizer is to increase temperature of feed water using waste heat of flue gases leaving the boiler through chimney. It is located before air preheater and after superheater and reheater in the path of the flue gases. Air preheater. The function of air preheater is to increase the temperature of air before it's supplied to the furnace using heat from flue gases passing through the chimney. Second one, steam turbine. The function of steam turbine is to convert the heat energy of steam into rotational power at turbine shaft. In modern thermal power plant, steam turbine generally has a three-cylinder tandem compound machine consisting high pressure stage cylinder, it is called HP, intermediate pressure stage, it is called IP, and low pressure stage cylinder, it is called LP. Third one, generator. The function of electric generator is to convert mechanical means rotational power of turbine shaft into electrical energy. The generator shaft is coupled to the turbine shaft. Fourth one, condenser. A condenser is a heat exchanger consists of large cylindrical vessel containing large number of brass tubes through which cooling water circulated and steam flowing outside the surface of tubes. The function of condenser is to condense the steam which coming from the low pressure turbine. Fifth one, cooling tower. The function of cooling tower is to cool the hot water coming from the condenser. In the cooling tower, the hot water is cooled with the help of atmospheric air. Sixth one, feed water pump. It is used to supply feed water means coming from the condenser to the boiler at a desired high pressure. Next one, circulating water pump. It is used to circulate the cooling water in the condenser and cooling tower closed circuit. Next one, coal handling plant. Wagon tripler. It is used to unload the coal when coal transported to the plant site by rail wagon. Crusher house. It is used to crush coal to a size of 10 mm. Then coal is supplied to boiler raw coal bunkers, coal mill. It is used to pulverize the raw coal into a fine powder before it is burnt in the boiler. Next one, drought system. The function of drought system is to create pressure difference which is required to introduce desired quantity of air to the boiler furnace and to carry away the burn product of combustion and discharge to atmosphere. FD fan means forced draft fan. FD fan is placed in front of boiler and it is used to push the air through the air preheater and then the furnace of boiler. ID fan means induced draught fan. ID fan is placed near the base of chimney and it draws flue gases through the interior of the boiler and dust extracting equipment and forces the flue gases to move through the chimney. Next one, ash precipitators. The function of ash precipitator is to remove fly ash and dust particles from the flue gases before these escape into the atmosphere through chimney to avoid air pollution. Next one, chimney. It is ferro-concrete structure lined with fire bricks. It is used to escape flue gases to atmosphere at 30 meters above the ground. Next one, water treatment plant. The function of water treatment plant is to remove impurities of water before water supply to the boiler. Thereafter, switchyard. The switchyard houses transformers, circuit breakers, and switches for connecting and disconnecting the transformer and circuit breakers. The electrically generated by the 11 kilowatt generator is stepped up by unit transform 132 to 220 kilowatt for the further transmission through high tension lines and fed to the regional grid. And last and final, control room. The control room houses all the necessary measuring instruments for each panel of generator, means alternator, and feeder, synchronizing gear, protective gear, automatic voltage regulator, communication arrangement, etc. The performance of all the plant equipment is constantly monitored here with the help of sophisticated instrumentation and controllers. Site selection of thermal power plant. First one, availability of coal. Modern coal-based steam power plant requires huge quantity of coal per year. A rough idea, a thermal power plant of 100 megawatt capacity requires 1200 to 1500 tons of coal per day. Hence, a plant consuming such a large quantity of coal should be located as far as possible near the coal mines in order to save the coal transportation costs. Also, if plants located away from coal mines, it may create problems due to failure of transportation system or strike at mines, etc. For these reasons, considerable amount of coal, at least 15-day coal supply, must be stored at the power station. However, it increases space requirements, staffs, costs, and losses of coal storage. In case it is not possible to locate the plant near the coal mines, then the plant should be connected to the railway. Second one, availability of water. In the steam power plant, water and steam is working fluid. Hence, large quantity of feed or makeup water is required. Also, huge amount of water required for condenser, cooling tower, and for disposal of ash. A rough idea, a thermal power plant of 100 megawatt capacity, the 30,000 to 50,000 tons cooling water required per hour. The cooling tower is used, then also 800 to 1000 tons cooling water required per hour. The makeup water required to compensate the loss of feed water is also 10 to 15 tons per hour. Further, the water must be pure as possible to reduce cost of water treatment for feed water. Therefore, while selecting site for the steam power plant, above factor must be considered carefully. It is therefore necessary to locate the plant near the waste source which will be able to supply required quantity of water throughout the year. Third one, ash disposal facilities. Ash is the main waste product of steam power plant. The handling problem is more serious than coal handling, particularly in India. Coal available in India is having large percentage of ash as 20 to 40 percentage because ash comes out in hot condition and it is highly corrosive. Its effect, its effect on atmospheric pollution are more serious as human health is concerned. A 100 megawatt steam power plant produces approximately 350 to 500 tons as per day. It requires 2.5 hectares area per year. If the S is dumped to a height of 6.5 meters, if the site is near the coal mines, it can be dumped into the disused mines. In case of site located near the river, sea or lakes, S can be dumped into it. Presently, S from power station is used for many industrial processes and brick making for construction work. Fourth one, land requirement. Land required not only for setting up the plant but for other purposes such as staff colony, coal storage, S disposal, etc. For 100 megawatt plant, the land requirement may be 300 to 500 acres. As the cost of land adds up to the final cost of the plant, it should be available at a reasonable price. Land should be also available for future extension. Fifth one, nature of land. The type of land to be selected should have good bearing capacity as it has to withstand not only the dead load of the plant but also the forces transmitted to the foundations due to operation of heavy machinery of plant. The minimum bearing capacity of the land should be 1 into 10 to 6 Newton per meter square. Sixth one, load center. The site of power plant should be as near as possible to the load so that the transmission cost and losses are minimum. However, a plant cannot be located near all the loads. In this case, CG of the loads is determined with reference to arbitrarily chosen axis. This CG is known as load center. Hence, in order to minimize the cost and losses, the plant should be located as far as possible near the load center. Next one, transport facilities. The power plant should be near the railway line for bringing the heavy machinery for installation and for bringing the coal. And then availability of labor. At the time of construction of plant, enough labor is required. Hence, there should be skilled and unskilled laborers available at reasonable rates near the site of the plant. Then after size of the plant. In case of small power plant, cost of transmission line is relatively high. Hence, it should be near to the load center. But in case of large power plant, the cost of transportation of coal, cost of water are relatively high compared to the cost of transmission line. Hence, power plants should be near the coal mine as well as water sources. Next one, public problems. Site selected should not any sort of nuisance to the neighboring areas due to emission of smoke, noise, water vapor, etc. Hence, plant should be located far away from the towns. And last one, future extensions. The choice of the site should allow for economical extensions consistent with the estimated growth of load. Merits of thermal power plant. Thermal power plant can be located near the load center if water source available near the site. Next one, thermal power plant is more flexible to use any types of boilers and fuels. The steam turbines can be work under 25% of overload continuously. Thermal power plant requires less investment cost and less space compared to hydroelectric power plant. Next one, thermal efficiency of thermal power plant can be increased when it works conjunction with gas turbine power plant. Thermal power plant requires less time for installation compared to hydroelectric power plant. Demerits of thermal power plant. First one, thermal power plant requires large quantity of water for boiler and condenser. The fuel is coal. Transportation cost is high, especially when the power plants are away from coal mines and has no railway sidings. It has a very high operating cost compared to hydro and nuclear power plants. The thermal power plant pollutes the atmosphere by fumes and residues of pulverized fuels. In thermal power plant, there is great difficulty experienced in coal handling. Thermal power plant is less efficient below 75% of load. Thermal power plant requires long times for erection and putting into action. In this below table, we can show the Gujarat thermal power station with capacity in megawatt. Gujarat thermal power plants. First one, Ukai thermal power station, 850 megawatt. Gandhinagar thermal power station, 870 megawatt. Wanakbori thermal power station, 1470 megawatt. Sikka thermal power station, 240 megawatt. Dwaran thermal power station, 220 megawatt. Kutch lignite thermal power station, 290 megawatt. Surat lignite thermal power station, 500 megawatt. Akrimota lignite thermal power station, 250 megawatt. Mundra thermal power station, 660 megawatt. And Sabarmati thermal power station, 400 megawatt. Thank you.